Hey there. Our next goal is to broadcast a chain when a new block is mined to the entire network. But a prerequisite to that is going to be starting multiple blockchain instances that can interact with each other. But right now, every blockchain app is conflicting and trying to run on the same port of 3000. In order to start up multiple servers of this blockchain application, they're going to need to run on different ports. One option is to pass in an environment variable for the port. But the process for passing environment variables is not consistent across the native command lines of operating systems like Mac and Linux, which are based on Unix versus Windows. So let's come up with a solution that should work cross-environment in terms of setting environment variables and allow us to generate a unique port for a second instance automatically. To facilitate this, we're going to install a new module called CrossENV, short for cross environment. As of this course, CrossENV is at version 5.2.0, and we're going to save this as a development dependency since we'll only need it in the development version of the project. So what CrossEnv does is it gives us a way to set environment variables programmatically no matter what operating system you're using, no matter what command line application you're using too. It was developed precisely to allow Node.js applications to work with environment variables no matter what machine you're using. All right, cool. So head to the package.json file of the project. We're going to go to package.json. And now we're going to use this CrossEnv module to set an environment variable called generatePeerPort. When we want to start a peer instance, so a second instance of this blockchain application, we're going to set this generatePeerPort environment variable to true. And let's do this within a new script called devpeer. So overall, we're going to use CrossENV to have this generatePeerPort environment variable. And environment variables are, by convention, usually screen case. And they're also strings, so when we set this equal to true, we're going to need to surround the true value with some quotes. And then what we want to fire is we want to fire this dev command, but we want to fire what it normally starts, which is nodemon index.js. All right, so overall to review, CrossEnv is going to set our generatePeerPort. We need this to be a string value for the environment variable, which is why true is surrounded by quotes. And then we're starting nodemon index.js like normal, as we would with the dev command. And now this will require some refactoring within our main index.js file. Essentially, we need to start up different ports for the application based on whether or not the generatePeerPort environment variable has been set to true. The first thing that we're going to do is we're going to distinguish a default port from a peer port. So the default port is going to be what we already have, 3000. But then we're going to have this ability to set a peer port, which will make dynamic and won't assign to anything for now. We'll check that if process.env.generatePeerPort, if this is equal to the string of true, well, we're going to set this peer port to something else. Let's set the port to the default port plus a random value between 1 and 1000 for the peer port. So we're going to say that the peer port is equal to the default port plus a random value from 1 to 1000. So this is pseudocode right now, but to actually get this value from 1 to 1000 with JavaScript code, we can call math.random, which gives us a decimal between 0 and 1. We'll multiply this by 1000 to get a decimal from 0 to 999.99999, and then we'll seal this whole thing so that we get a whole number from 1 to 1000 based off of that. All right, cool. So we have the default port plus a random value from 1 to 1000 for our peer port. So if the peer port has been set, well, let's make sure that the port becomes that peer port. Otherwise, if the peer port is undefined, we can capture this with an OR operator, and we'll set it back to the original default port. Cool. So this will make it so that when you run the application normally, with npm run dev, generatePeerPort is not going to be set. Therefore, peer port will remain undefined, which means that the port won't go to the undefined peer port, it'll go to the default port, and the main application is still going to run on localhost 3000. Otherwise, if we start a peer with the dev peer command, generatePeerPort is going to be true. Therefore, peer port is going to be some value between 3001 and 4000. And then port is going to immediately pick up the defined peer port and then set that for the peer, and it's going to listen at localhost xxxx. All right, cool. So let's try this out. In the command line, first up, we're going to start one instance with npm run dev, and then this starts the Redis server, and we get the message of listening at localhost 3000 for the main application. Cool. Now how about running a peer? As we do this, generate peer port has been set to true, and the result is that we get the application starting at a random port value. So in this case, it's 3575, but if you start this over and over again, it's going to be some other random value between 3001 and 4000 and different every time. Well, very cool. So now we've started up the main app and we have a peer going as well. And notice that when we started up the second one, it broadcasted its chain to the original instance. Cool, so we got communication going between multiple instances of the blockchain application. Very cool. Now that we have this, we can update our application to broadcast its chain whenever a new block is added through the API mine request. So back in the code, in the main/API/mine method, the post request, we need to make sure that the new chain is broadcasted with this additional block. So right after blockchain.addBlock, we'll add a call for pubsub to broadcast the chain right away. We'll call pubsub.broadcastChain right after addBlock is used. As we save this, both the main node and the peer node should have picked up the changes thanks to nodemon and restarted. So if you head back to the command line, you'll find that, well, now there's a new peer port for the second peer, and the actual main application should have restarted as well. So now we want to check if we post to this main node, is this going to be fired to the second peer application, and is that chain going to be picked up? Well, let's try with Postman. Go ahead and make a post request to localhost 3000/API/mine. You're going to want to make sure that there is a body properly configured for this. So head to the body tab, go to raw, application JSON, construct a body with valid JSON data, so make sure everything is surrounded by double quotes, and make sure the headers are present as well. And once you have the post request to HTTP localhost 3000/mine, or rather 3000/API/mine, go ahead and send this overall. And with that, our response is a whole blockchain for the main application, which is great. But the thing we want to check is in the command line. Well, look at that. Message received on the channel blockchain of the second peer, so the second peer instance, and great, it got the new blockchain array consisting of that foo data that we just created within the main application. So it definitely broadcasted its chain when it added the new block. Awesome. Now that we're working with multiple blockchains, the next piece to add to this application is synchronization on the startup of subsequent instances of the app. For example, if I was to start a second peer, so npm run dev peer here, this is starting up, but its blockchain is not currently in sync with what is the longest blockchain in the application. Its blockchain is still the default one with only the Genesis block, but we know that the main application and the original peer had that longer chain because it already had some interaction with some API/mine requests. Therefore, we need a solution for this. We want new peers to be synchronized right away. So let's accomplish the synchronization next.